Okay, this is exam 1 for Physics 201, Fall 2016. Which of these best approximate the area of a twin mattress? Okay, a twin mattress is about 2 meters by 1 meter, about 6 feet by 3 feet, so it's 2 square meters. The mass of your desk is approximately, it's about 25 pounds. 25 pounds, that's about 10 kilograms. A kilogram is a couple more than a little more than a couple of pounds. How many sig figs should the solution for this have? Okay, well here I have 1 decimal place and here I have 2 decimal places. So this top part is going to come out to be, 15.7 divided by 4.92. So I'll still have 3 sig figs up here, although just 1 decimal place, 3 sig figs in the bottom, so it's going to be 3. Consider this following right triangle. What is the angle theta? Well, tan of theta is 4.2 over 5. So theta is the inverse tan of 4.2 over 5, and that is equal to, 40 degrees. Standard for the meter is based on the distance light travels. The speed limit is 80 kilometers per hour. What is this in meters per second? Kilometers per hour. 1 kilometer, 1,000 meters, 1 hour, 3,600 seconds, and that is equal to 22 meters per second. You drive for 30 minutes at 30 miles an hour, and then for another 30 minutes at 50 miles an hour. The average speed is equal to 40 miles an hour. You can think about this, since I'm traveling the same time at these different speeds, I just average these two numbers. Or I can imagine I drive for 30 miles an hour. At 30 minutes, I drive 15 miles. At 50 miles an hour for 30 minutes, I drive 25 miles. Divided by 1 hour, that is equal to 40 miles an hour. You drop a rock off a bridge. Which of these describes this? This was straight from the concept test. It is the velocities both increase at the same rate. You move on this track. What is your displacement? Moving from A to B. That's going to be -1 minus 3. -1 minus 3, final minus initial. That is -4. You throw a ball upward with initial speed of 10 meters per second. What is its speed when it returns to you? Equal to 10 meters per second. It goes up, comes down at the same speed. Consider this position versus time graph, which represents the velocity versus time graph. Well, you initially have a big positive velocity, and that gets smaller. Big positive velocity, smaller positive velocity. So C is right. And 12, describe the motion of this object for these 3 time periods. Here the object's not moving. Here the object is moving in the positive direction, and it's speeding up. And then here it's moving with a constant speed, a constant non-zero speed. So let's see, let's go through this. The object is traveling at constant speed. It's traveling at 0 speed. That could be correct. Has a negative acceleration. Actually here it has a positive acceleration because it's speeding up in the positive direction. So this one goes away. B, object is not moving. Check. Object has an increasing speed in the positive direction. Check. It's traveling at a constant positive speed. This is a positive slope, so check. So B is the right answer. These other two are not correct. It does not have a constant non-zero velocity. It has a constant 0 velocity. The object is in the same position, does have a positive acceleration, but it does not have an increasing speed in zone C. All right, let's look at these free response. And most of your points come from this 70 points. And so you should spend most of your time on it. Here's the function, 5t squared minus 20t plus 10. There's the graph. What is the average velocity between t equal 1 and 5 seconds? I'm going to do that one right here. Between t equal 1 and 5 seconds, what is the average velocity? That's delta x over delta t. X final is 35. X initial is minus 5. 35 minus -5 divided by delta t. I'm going from 1 to 5, so that's 5 minus 1. That's 40 over 4 equals positive 10 meters per second. Graphically, find the instantaneous velocity at t equal 4 seconds. So at t equal 4 seconds, that's right here. I'm just going to sort of try to find the slope of this line. My rise here is positive. it goes from about, oh, that's about 30 down to negative 15, so that's positive 45 is my rise. And then my run here looks like, about 2.8 to 4, or excuse me, 2.8 to 5. That's what, 2.2. So roughly 45, 2.2, I get about 20.4. So for B, my slope, which is rise over run, 45 over 2.2, is about 20 meters per second. I want to see that work for how you found this. Show how you do this on the plot. What is the function for the velocity and for the acceleration? All right, so for C, the velocity is the derivative of that function. That's going to be 10t minus 20. And my acceleration is the derivative of this function, which is just going to be 10. That's it for C. D, calculate the velocity at t equal 4 seconds. Equals 10 times 4 seconds minus 20. Oh, that's equal to 20 meters per second. That better be what it is, because that's what I found it to be up here. All right, so you can go back and check your answer. That is D. And then sketch the velocity versus time graph for this, and I provide you the axes. It starts out with a negative velocity. It goes up to right here where it gets a zero velocity. See, the slope of this line is zero, and then it has an increasing positive velocity, so it's going to look like that. This is at t equal 2 seconds. I didn't require you to do this, but you should know it regardless. And the acceleration here is 10, so the slope of this line should also equal 10. All right, so that's what the graph should look like. Show whether these equations are dimensionally correct. If correct, say yes. So let's do 1 meters per second equals meters per second squared times meters square root. That's meters squared. So it's meters squared per second squared under that radical. So this one does check out. So that one's correct. For 2 meters, meters per second squared plus meters per second. Those cancel, give me meters, meters, meters. So this one's okay. And then this last one, 3 meters, meters per second, leaving off the 2 because it's a constant. Leaving out the negative 3 there, I get meters, meters per second squared, because it's v squared. A is second squared over meters. I just flipped this because it was in the denominator, and here I have 1 over meters. I get some things canceling out here, 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 and here. Those all cancel out. This also cancels, so I'm left with meters, meters, meters. So this one is also checks out. So they're all correct. Derive the equations of motion. Begin with differential definitions for acceleration and velocity. So let's first begin with this. Integrate both sides. V is equal to A times T plus my integration constant, which is V naught. That's the first one. Then I start with V equals dx dt. That's my definition for velocity. Dx is equal to V dt. Make that substitution from our previous derivation. Integrate both sides, and I get x equals V naught t plus 1/2 at squared plus my integration constant, which is x naught. And so that's the other equation. Those are your 2 kinematics equations derived from first principles, our definitions of what is velocity and acceleration. Consider the following graph of velocity versus time. What is the average acceleration between t equal 2, right here, and t equal 8 seconds? So for A, this is similar to what we had before. I'm going to do average acceleration is delta v over delta t. That's going to be 12 minus 4 divided by 8 minus 2. That is, sure I did that right. 12 minus 4, so that's 8 over 6, which is 4/3. I'm sorry, I need to pause this for just a second. Okay, so it's 4/3 meters per second squared. It is positive, as you would expect from looking at the graph, because if I were to draw a line between these 2 points, it would be positive. Okay, what distance does he travel from 0 to 12 seconds? In this case, I need to know the area of this and the area of this portion. So I can find the area of both of those. This area is going to be 1/2 base times height. That's 1/2 of 0 to 4 times the height 0 to 12. So it's 12. This is B. The first part is 2 times 12, has an area of 24 meters, plus the area of this portion. I go 4 to 10, that's 6 times 0 to 12, 12, that's 72. So I get 72 meters. Add those up, 76, what's that? 96 meters. And then the third part, you're supposed to draw the position versus time graph that represents this motion. All right, well, first I have x versus t like this. This first part, my velocity is positive and increasing. So it's going to look like this, a velocity that's positive and increasing. And then in the second part, the velocity levels off and it continues at the same rate. And so that means I'm going to have a straight line. The slope here will equal to 12 meters per second. Slope here in this part is increasing. You throw a ball upwards, it travels to a height of 20 meters before turning around and returning to your hand. These are probably the most difficult problems on the test. No, maybe not. So let's just first write down everything that I know. So y is equal to 20 meters. It travels up to a height of 20 meters. So I throw something up. It comes up and comes back down again. I'm calling this my 0. And so this is equal to 20 meters up here. I know my acceleration because this is free fall. It's vertical motion. It's 10 meters per second squared in the negative direction. I don't know what t is. I don't know what v naught is either. I do know that v top is equal to 0. So the first thing I want to know is the time. First, I'm going to write down my equations. Y equals v naught t plus 1/2 a t squared. And then v is equal to v naught plus a times t. Then I like to write down what are all the unknowns that I have in these equations. Well, I don't know v naught or t. So notice that I have then a system of 2 equations with 2 unknowns in each equation. I need to solve for both t and for v naught. The way I'm going to do this is I'm going to first I'm going to solve this equation for v naught. V naught is equal to v minus at. But remember, v is 0, so I'm just going to get rid of that. V at the top is equal to 0, so I'll be solving then for t at the top. Now, I can take this and plug it in right here for v naught, and that's what I'm going to do now. I say y is equal to negative at times t plus 1/2 at squared. This is negative at squared plus 1/2 at squared, which is negative 1 plus 1/2 times at squared. So y is negative 1/2 at squared. All right, so now I know everything here but t. Y is equal to, that's what was y equal to, 20 was negative 1/2 times a, which is 10, times t squared, and I solve that for t. And it works out that t, it should be negative, t is equal to 2 seconds. So it takes 2 seconds for it to get up here to the top of the trajectory. Now, if I want to also know what is v naught, which I do, I know that v naught is equal to negative a times t, which is negative 20, negative positive 20, negative times negative 10 times 2 seconds, positive 20 meters per second. What is the position of the ball at t equal 3 seconds? So for C, y is equal to v naught t plus 1 half a t squared. That is going to be 20 times 3 seconds. That's just the time that I give you. Plus 1 half of negative 10 is negative 5 times 3 squared. That's 60 minus 45 are 15 meters. So at 3 seconds, this ball is right about here. It's at 15 meters coming down. And now I also want to know what is the velocity at 2 seconds. Well, you might just know this right off, but at 2 seconds, v is equal to v naught plus at. That's equal to 20 meters per second. That's the v naught that I found here, minus 10 meters per second squared times t, which is 2 seconds. I just give you that. But we already found that t at the top is 2 seconds, and we also know that the velocity at the top is 0. So 0 is the right answer. If you just wrote 0 there, I gave you credit because you should be able to reason it from what we've already gotten. Okay, this next problem requires 2 steps. A slap shot hockey player accelerates the puck from a velocity of 5 to 30 meters per second in the same direction. There's the time. I want to know the distance. So let's write down everything I know. V naught is 5. V final is 30. T is 0.02 seconds. I don't know X and I don't know A. So I first need to find A. To find A, I say V equals V naught plus AT. I know everything here but A, so I say A is V minus V naught over T. That's going to be 30 minus 5 over 0.02. That's equal to 1,250 meters per second squared. Then I find X. V naught T plus 1 half AT squared. V naught is 5. T is that 0.02 or 2 times 10 to the minus 2 plus a half, a 1250. It is positive. It's accelerating in the positive direction times 0.02 squared. And that gives me my value for X, which is 0.35 meters or 35 centimeters. And that's the right answer.